Hey, this is Mr. Hansen. I want to pick up from the last lesson. We looked at a lot of uses for the coordinate plane, and it was more or less a review. Today we're going to look at some new things that you can do on the coordinate plane. So the first thing here says measuring an angle on a coordinate plane. As you recall, an angle has two rays and a vertex. We're going to put the vertex right there at the origin. And the first ray we're going to put going along the x-axis here, and we call this the initial ray. And then from there we can do a terminal ray, and if we put it right here, then you'd have, if it was halfway to the next quadrant, you'd have half of 90 degrees, which is 45 degrees there. So there are some landmark features you need to recognize. We could count by 45s. This one would be 135 here, and let's make another ray right here. This one would be way over here. That's 180, which you know from a protractor, plus another 145, so that's going to be 225 there. And then this one's going to be, if we went way over here, that's going to be 270. And if we did another 45 degrees, if we went way over here, that one's going to be 270, and 45 is 315. And then the final one, it's doing a 360 all the way around a circle. So that's kind of how that works. You kind of need to see this backwards too. That's actually going forwards. Counterclockwise is going forwards in this case. But if we were to do something like this, we just said that was 315 degrees. It could also be called, if we went this direction, negative 45 degrees. So negative 45 degrees. And if we went this far, that'd be negative 90. And this would be negative 180, and so on. So if you go clockwise, it's going to be negative. If you go counterclockwise, it's going to be positive. And here's one last thought for you. Could you go multiple times through a circle? Could you do something like this? Sure, you could. You could have an angle measure that measures 720 degrees. That's twice through the circle. And if you think about something that rotates maybe like a Ferris wheel, it's like a Ferris wheel turning. You're starting at the bottom, you get on, you turn all the way around, there's 360, and then you turn all the way around again. You have gone 720 degrees around that circle. So I hope this kind of helps you get an idea how to plot angles on a coordinate plane. Just remember, your initial ray is always the one that shoots off the x-axis from the origin there, and then your terminal ray. If you're going counterclockwise, your angle will be positive. If you're going clockwise, your angle will be negative. Let's look at the next page. Putting a unit circle on a coordinate plane. So here we've got, I put from the origin to here is one unit, even though there's 3 grid marks there, we're using it as 1 unit. So we've got the x-coordinate 1 and the y-coordinate 0. And then you've got the x-coordinate 0, the y-coordinate 1 right up here at 90 degrees. And then here at 180 you have x is negative 1 and y is 0. And then at 270 you have x is at 0 and y is at negative 1. So these are kind of some landmark features of this circle. But maybe there's a question here. What about other points on the circle? Can we figure out what they are? And if you had this line segment right here, it is a radius of the circle. And we know the radius here is 1 and the radius there is 1. So the radius has got to be 1. So I'm going to drop a perpendicular down and a horizontal over, and I've put this over on the bottom right here. And let's figure out, when the radius is 1, could we figure out, well, I'm going to call this one x, and I'm going to actually call this one y here. Well, let's keep them both x for a minute so we can solve. When the radius is 1, we've gone kind of halfway up the circle, so we're half of 90 degrees. We're at 45 degrees here and 45 there. And if the base angles are the same, then I'm going to clean this up just a little bit. If the base angles are the same, then then we know that this is an isosceles triangle. That's why I put x on both of them. And let's go ahead and solve for x. So x squared plus x squared equals 1 squared. So we've got 2x squared equals 1. Divide by 2, and x squared equals 1/2. So what number equals 1/2? What number times itself equals 1/2? It's the square root of 1/2, and if you plug that in your calculator, it's going to be like 0.707. So here we have 0.707 and 0.707, 0.707, comma, 0.707. Okay. Now let's populate our circle with a few of these. Can you also see a 45-degree triangle right here? So this is at 135 degrees, but it's also going to be 0.707, comma 0.707, except this time the x is going to be negative. So there you have it. And this one, negative 0.707, negative 7.707. And finally over here, the x is positive, but the y is negative. Something like that. Okay, so we're getting some points on the circle, but maybe the question is, how could we find any point on this circle? And the way to do it is by relating it to an angle measure here. Here we had 45 degrees. And let me just do a little more drawing space so you can kind of see how this works. Here's my quarter of a circle. I'm going to try it. This is 30 degrees here. And then you start thinking of your trigonometric functions. So we know that the hypotenuse is 1, and then we know that the let's say that this leg here is y, 1 and y. And so let's go opposite over hypotenuse. So sine at 30 degrees equals 1 over y. And we could switch this around and say, I'm sorry, it's y over 1. It's opposite over hypotenuse. Let me clean that up. So sine at 30 degrees equals y over 1. Y over 1. And when you put sine of 30 in your calculator, it's just a ratio of this leg compared to that leg. And it's we're going to have sine at 30 is going to be 1/2. This leg's half as large as that hypotenuse there. And so you could put 1/2 right here for y. And if you put cosine 30, it would also give you a number. It's going to be larger than 1. It's going to be quite a bit larger than 1/2, but less than 1. And it's forgive me, I've forgotten the decimal value, but it's square root 3 over 2. Okay. So using sine and cosine, you can kind of populate all the points on this circle, and you can from there you can kind of if you need to find an angle measure or you need to find a side length, you can do that. Kind of interesting. The x value is just cosine at that angle, so cosine 45, and the y value is sine at that angle there. So sine 45, this is going to be cosine 30 and sine 30, and so on. So I hope that helps you a little bit. We'll practice that. But putting a unit circle on a coordinate plane, that's kind of what we're doing there. Let's take a look at one last thing. We've got the makings of a unit circle here, and I'm gonna take the time to put in these 45-degree intervals. So 0.707, comma 0.707, negative 0.707, comma 0.707, and negative 0.707, comma negative 0.707, and finally 0.707, comma negative 0.707. So there you have it. And so what I'm going to do is I'm going to kind of turn this into a function use the coordinate plane again, turn it into a function. And I'm going to go in intervals of 45 degrees across the x-axis. That's kind of my input. So I'm going to go, this is like 45, this is 90, this is 135, this is 180, this is 225. I wish I had more room. This is 270. Maybe should have gone a little smaller, but let's do that. So at 90 degrees, we are at 0, 1. So 0 on my x. Oh, let's do this. I'm sorry. Let's do the sine function first. Sine of x. So sine is your y values. So I'm just going to kind of underline them here. So at 0 degrees, we are at 0. We're going to start right there. At 45 degrees, if this is 1 here, we're at 0.707, so about right there. And then at 90 degrees, we are at 1, about right there. And then we're back down to 0.707, right there. And we're back down to 0 right there. Notice it's kind of made kind of a graph shape like that. And then at we'll be down to negative 0.707 at 225, and then we'll be down to -1 right there. So it's going to kind of go like this, and then it shoots back up like that. And I wish I had a little more room. I'm going to kind of show you what it looks like if you have a lot more room. Kind of looks like this. Okay, so it's called a sine curve, sine function, and if you're thinking about where you're at on a Ferris wheel in terms of maybe how high you are off the ground, you just have to think of your angle measure, and you plug your angle in. That's your input, and then you can figure out how high you'd be off the ground. This is kind of the maximum, and then the minimum, and then the maximum, and the minimum, and so on. And your angle measure would tell you that. So here, if you had an angle measure of 90 degrees, you're right here, and then at 180 you're down there, and so on. So another use for the coordinate plane, you're actually putting information from the unit circle onto a sine curve. So 3 things. We did the sine curve, we did the unit circle, and we did how to plot an angle on the coordinate plane. There is really a lot to this, so plan on learning a little bit more about this in more depth. Thank you very much.